Good evening everyone. Good evening. Let me know audio video okay or not. Let me know audio video okay or not. In the last class, I think we done the problem number 5. Now let's go to problem number 6. Today we will start problem number 6. Right? I think today's date is 26 or 25. Yeah, I think 26. Check one time. Today's date is 26. Please let me know is it 26 or not. Otherwise, I will go and check one time. In the last class, I written also. Let's check. I forget in the date. Just wait. I have to save. Just wait. Yeah, this is the yesterday's class. Let me go ahead. So yesterday's class, from where it is started? NFA, DFA, I think here. So this is C. Yesterday's date is 25. Let's go to today's. Let's go to today. Today's date is 26. Today's date is 26. Yeah. In my opinion, today's class is just started now. Thanks everyone. Let me start. Thanks everyone. Let me start. So let me write now. I'm writing the problem. Construct. I hope audio video okay. Those people who are watching, please let me know audio video okay or not. Right? Yeah. Any doubt there in the comment section? You can comment. Construct minimal DFA for the language L is equal to epsilon. Right? One more. For the language L2 is equal to pi. Pi means empty language. This is going to be very tricky question. Construct minimal DFA for the language L1 is equal to empty string. For the language L2 is equal to pi. Remember, L1 is not empty. It is not empty language. Not empty language. Please try to understand. But L2 is empty language. Language empty means nothing there. Empty language. See, in the L2, nothing is there. In the L1, something is there, but which is empty? This is called empty string. Epsilon is empty string. Epsilon is empty string. It is a string, but it is an empty string. Epsilon is empty string. Now I will say one by one. Please understand, it is a very, very important one. L1, L2. This one, L1, L2. L1, not empty. L2, empty. Okay, that is the first one point. One more point. L1 is not empty, but L2 is empty. L1 contain one string. It contain one string. It contain 0 strings. 0 string. L1 contain one string. L2 contain 0 string. Because of 0 string, it became empty language. Because of it contain one string, it became non-empty language. And one more thing. L1 is not empty. L1 contain one string. What is that one string? It is an empty string. Epsilon. That one string is epsilon, which is empty string. Empty string, language not empty, it is empty string. But here if you observe, right, here nothing is there, right? Pi nothing is there. So no string is there. No string. Forget about empty string. No string. Right? Now some people are asking, sir, how you write the automata for this? Please try to understand everyone. How to write automata for this, right? L1 purpose I am writing. See the L1, interesting answer. L1 contain epsilon. Only one string, because of that reason it is non-empty, okay. That string length is 0 length. That string length is 0 length. If it is string length is 0 length, 0 plus 1 with one state start automata. With one state start automata. See, let's see. I'm starting with one state start automata. If one state is there, starting state, final state, same. Remember, in any DFA or in any automata, starting state, final state, same. Epsilon accepted. Epsilon is accepted. And let us assume, everyone observe. L1 is not empty, so L1 is epsilon. L1 want to accept only epsilon. Not more than epsilon, not less than epsilon. Let us assume if someone say L1 alphabet is A comma B. Suppose someone said that L1 alphabet is A comma B, sigma is A comma B. Then see the answer. This automata already accepting epsilon, right? If at all, because of the DFA, I have to cover unnecessary also. A also go to S2, B also go to S2. S2 is a dead state. Dead state will go itself. If anyone say L1 alphabet, if anyone say, in the problem he mentioned L1 alphabet is A comma B, then this is. Suppose alphabet not there. If no alphabet, then you no need to write A comma B. Simply one state is enough. So if someone said to you L1 alphabet is A comma B, L1 is empty L1 is empty string. L1 is not empty language. L1 is empty string. Right? So this is the automata for this. If sigma is A comma B. Suppose sigma is not there, one state is enough. Sigma is A comma B, then two states required. That is L1. Let's go to L2. Interesting. L2 is interesting. Please understand everyone. L2 is pi. Right? See the answer. Pi means what? 0 length. Right? Pi means no string. No string means no need to accept. Then what you do is write only one state, because you don't want to accept anything, no requirement of any final state. Suppose L2 also someone is mentioned, sigma is A comma B. Then what you do is on S1 A comma B, then go to S2. But anyhow, S1, right? No final state. If you go itself also, no issue. Now, if you want, you can check no final state, nothing will accept. Nothing will accept means empty language. Nothing will accept means empty language. Sir, is there any requirement of dead state? Of course, no requirement. Why? Whatever state is there, that itself is dead state. Whatever state is there, that itself is dead state. Sir, I will take S2. I will go from S1 to S2 by giving A comma B. Then what is the answer? Then S2 also dead state. Whenever no final state, everything is dead state only. Whenever no final state, everything is dead state, because wherever you go, string rejected. Remember, S1 is accepting, right? Remember everyone, L2 accepting empty language, right? But if you see L1 is not accepting empty language. L1 accepting something, right? Whose string length is 0. Means string may be empty string, but L1 is not empty language. Remember here, language not empty. Here, language empty. Why language empty? No final state. So nothing will accept. Right? Language empty. Why? No final state. So nothing will accept. These 3 points. Language not empty. Why? Final state is there. Right? It means something it will accept. Because of starting state, final state both are same. Epsilon accepted. Right? Fine. Perfect. I feel you are getting. I feel you are getting what I am saying. This problem is very, very interesting. What is the problem? Construct minimal DFA for the language L1 is equal to epsilon, L2 is equal to pi. For L1, if sigma is A comma B, two states, minimal DFA. For L2, if sigma is A comma B, right, then I think one state enough. Because of you don't want to accept anything. You don't want to accept anything, so no final. You don't want to accept anything, so no final. So I think a problem number 6 also everyone is comfortable. Some people are asking, sir, for this problem, what about N of A, sir? L1, right? L1 language N of A, see once starting state, final state, same, epsilon accepted. AB, because of it is N of A, na? If it is N of A, AB, you no need to mention because it is not your requirement. If it is not your requirement, you can ignore. If it is not your requirement, you can ignore. So minimal NFA contain one state. Minimal NFA contain one state. Minimal DFA contain DFA two states. Because sigma is this. Here also sigma is A comma B. That's fine. But NFA means unnecessary things you don't cover. Only necessary things you will cover. Only necessary things you will cover. Some people are asking, sir, for L1, what is the regular expression, sir? For L1, what is the regular expression? Only one string, na? What is the regular expression? That itself. L1 is equal to epsilon. Sir, for L2, what is the regular expression, sir? Only one, na? Nothing. Why? What is there in that? When more coming, how to represent regular expression? See, regular expression is one way of representation. If more people are there, how to represent? We'll see irregular expressions one by one. If more people are there, how you represent? Right? Then there is a meaning of regular expression. If only one there or nothing there, what is there in that? That itself you write. This itself is regular expression. Regular expression. This itself is a regular expression. Okay, perfect. Perfect. I feel everyone is comfortable. Problem number 6 also completed. Problem number 6 also completed. Let's go to problem number 7. Let's go to problem number 7. Be careful, everyone. Construct minimal DFA for the language L is equal to. Construct minimal DFA for the language L is equal to. Please listen, everyone. Please listen, everyone. Construct minimal DFA for the language L is equal to. Right? So let me write. All strings of A's and B's. All strings of A's and B's where each string contain triple A as substring. So this is the problem. Construct minimal DFA for the language L is equal to all strings of A's and B's where each string contain triple A as substring. Right? So if any problem is given, let us assume you don't know anything. Right? So how you construct automata for this? You don't know anything. How you construct automata for this? Everyone try to understand. Please follow like this. First step. What is the first step? For the L, list out strings one by one. Right? For the L, list out the strings one by one. What is the first one? Right? What is the first one? All strings of A's and B's where each string contain triple A as substring. Everyone know every string is substring to itself. Every string is substring to itself. Right? Everyone know. So minimum is triple A. Okay. And next one is a triple A confirm anywhere. Triple A is confirmed, right? Before triple A, anything can come. Anything means sigma star. Next one, after triple A, anything can come, sigma star. And before and after, anything can come. So this is like this. You can write many. Before triple A, anything, yes. Sir, before triple A, nothing also, yes. Anything contain nothing also. Before triple A, anything, yes. In anything, one of the person is epsilon. If you take epsilon, right? One important thing. Can everyone listen? Everyone listen. Epsilon dot A. Remember this. A dot epsilon A. This dot operator is called concatenation. Right? What is the meaning of A? Epsilon dot A is A. What is the meaning? 0 length plus 1 length is 1 length. Next one. 1 length plus 0 length is 1 length. Understand? Next one. Next one. Can you see this one? Epsilon before, epsilon after is A only. See, 0 length, 1 length, 0 length, which will goes to 1 length. So remember, for every string, before epsilon by default there, afterwards also epsilon by default there, because epsilon into anything is anything. Right? Anything into epsilon also anything. Please remember this. This is the only thing which you have to remember. Yesterday I written also. In the TOC subject, the hero is epsilon. If you learn epsilon properly, TOC subjects you got. In the TOC subject, the hero is epsilon. Learn epsilon properly. Right? So that dot is called concatenation. Concatenation means combining two strings. Right? If you combine 1 length string, 2 length string, concatenation if you do, 1 plus 2 become 3 length. But here you are concatenating a null string, means empty string. Empty string means nothing. Right? 0 plus 1 is 1 only. So this is very, very important, remember. So before AAA, anything can come. After AAA, anything can come. Before and after, anything can come. Right? So remember, minimal string is AAA. So 3 length. 3 length is minimal string. So 3 plus 1, 4 states. With 4 states start automata. 4 states start. S1, S2. Understand this procedure I am saying. S4. Final one is final state, starting one is starting state. So on the edges keep the first string. On the edges keep the first string. Observe, remember, I have to construct a DFA. I have to construct DFA and one more minimal DFA. Understand this also, minimal DFA. Now remember, I came to S4 means already I seen AAA. I came to S4 means already AAA happened. See, already AAA happened, then I go to S4. Every state will remember something. You came to S4 means AAA already you seen. After AAA anything, no objection. Next one more thing. After S1, AAA will come. After S1, AAA will come. Before AAA, any number of A's and B's should come. Any number of before and afterwards AAA will come. Before AAA, anything can come. I can write A comma B also, but it is a DFA. Already A there. Don't write A. On S1, after S1, AAA will come. Before AAA, anything will come. Anything means A comma B you can write. But already S1 on A there. Please write B. Otherwise it will become a N of A. Because on the S1, A two behaviors. That is also correct, but it is a N of A. It is a N of A. Please be careful. So S1 AB covered. S4 also AB covered. What about S2? What about S3? I have to cover. Everyone understand. You came to S2 means in the AAA already 1A came. You came to S3 means in the AAA already 2A's came. You came to S4 means in the AAA already AAA came. After AAA anything no issue. So A comma B. So remember if you come to S3 means AAA already AA came. After double A, one more A, you will go to final because you want triple A. But let us assume after double A, one more A, I will go to S4 because triple A came. After double A, one more A, I will go to final. After double A, if at all B comes, see, after double A, if at all B comes, I want continuously 3 A's. Now this sequence is gone. Again, you have to start triple A. Then, so if B comes, go to starting and say again start triple A. If triple A mismatch in between, again go back to S1 and say, please give triple A. Same way. After single A, I am at here. After single A, 2 more A's, I will go to final. After single A, if B comes, I think the sequence is failed. Then again triple A comes. So I think B, go here. So that's it. It is a DFA check. You have to remember AAA. You have to remember AAA. You have to remember AAA. Everyone goal is this only. Everyone want to help to remember the AAA. S1 is saying that after me AAA comes. S2 saying that in the AAA already 1A happened. S3 is saying that in the AAA already 2A's happened. S4 is saying that in the AAA already 3A's are happened. 3A's followed by anything. Right? Check once. So this is the minimal DFA. I think 4 states. Minimal DFA, 4 states. Because minimal string is 3, 3 plus 1, 4. 4 you started, but luckily you don't need extra. See, 4 states for starting purpose. But luckily, sometimes what happened is, you may start with 4, you may end with 4. You may start with 4, you may end with 4. Sometimes you will start with 4, you may end with 10 also. If requirement is there, I will increase. Some people are asking, sir, this is the DFA and it is a minimal DFA also. What about NFA? You no need to construct specially NFA. Every DFA is NFA. Every DFA is NFA. But remember, every NFA need not be DFA. Is it DFA? You have minimal DFA? You no need to construct NFA. That itself is NFA. You have a DFA. That itself is a NFA also. But is it minimal or not? I don't know. Every DFA is NFA. But every NFA need not be DFA. I'm repeating once again. This is a very tricky line. Right? So if you have a DFA, that itself is NFA. But minimal in the DFA, maybe more states are there. Because dead state and all. NFA may not having dead state. But if you observe this diagram, no dead state also here. See, everyone can go to final. From S1, can I go to final? Yes. So S1 is not dead state. From S2, can I go to final? Any chance of going to final is not a dead state. S3, can I go to final? Yes, S3 is not a dead state. S4, can I go to final? Itself is final. From any state, you cannot reach final, then it is a dead state. So here, no one is dead state. Means this is the DFA, this itself is NFA. And one more, it is a minimal DFA, it is a minimal NFA also. It is a minimal DFA, it is a minimal NFA also. It is a minimal DFA. So if you have DFA, that itself is NFA. Fine, perfect. And as I mentioned to you yesterday, right? I am saying again now. See this everyone? One crash batch is started. TOC, one crash batch is started. TOC subject is going on 7:30 p.m. every day. 7:30 p.m. every day. So I can say happily, right? You can join the crash batch. You can complete the syllabus as faster as possible. As faster as possible, you can complete the syllabus. And one more, 28th August onwards, right? RIC batch is starting. 28th August onwards, RIC batch is starting. So I request you, right? If you are serious about GATE examination, you can happily join RIC batch. Right? In the last year, 40 plus questions came from RIC. RIC and test series, 50 plus questions came. Right? 50 plus questions came from RIC and test series. It will be really beneficial for the last 6 months. Right? So if you want to get nice rank, I suggest you happily and proudly, so you can happily join the RIC course. Now come here. Now. Why to join EPT? So there is a live also, recording also. Right, and one more, in the RIC course and test series, most of the questions are expected. Many questions are guaranteed. Many questions. Last year 40 plus came. This year we are thinking 50 plus may come. Right? Most of the things are almost same will come. Right? Because I am guiding from 2007. 2007 onwards I am guiding. 2007 onwards I am guiding. So most of the questions are expected things will be there. Prices are as minimal as possible because I want to make sure, right? Education is not for the profit purpose, it is a service. Education is a service. We want to keep as minimal cost as possible. You please go and check, you will find out very minimal cost. And we don't teach anything unnecessary, all are examination oriented. Examination oriented. Exam prep tool for the purpose of exam oriented. Right? Fine. Fine. Next. Next. So can you see this? Can you see this one? These are our last year toppers. I wish next year I will see you also in the toppers list. Next year I will see you also in the toppers list. And one more thing is, right? So if you are studying in some college, you are there in the class top 5. In the class top 5, if you are there, you are eligible for EPT Rise 1000 initiative. For 1000 student, EPT subscription will be given freely. The only thing is 2000 rupees for platform and GST, right? These are the things which we cannot avoid. So 2000 rupees for platform fees plus GST combinedly. So we will give the EPT course freely if you are there in the top 5 of your class. And if you got the last year GATE examination, right, 2000 rank or less than 2000 rank, we will give the EPT course freely. You can utilize this through EPT Rise 1000 initiative. Last year 200 people we given course freely. Now this year we are giving 1000 people freely. You can utilize. It's almost free. It's almost free. Now come to the next one. Come to the next one. Go to the next one. Problem number, I think 6 over. Yeah, 7 over. Let's go to 8. Problem number 8. Problem number 8. Construct minimal DFA for the language L is equal to, careful this also, construct minimal DFA for the language L is equal to all strings of, this is also very important, all strings of A's and B's. Construct minimal DFA for the language L is equal to all strings of A's and B's where each string contain ABB as starting substring, right? And the problem number 9 also I am writing. Problem number 9 also I am writing. Please be careful here. I am writing problem number 9. ABB as ending substring. So problem number 9. So we'll see these two problems. Construct minimal DFA for the language L is equal to all strings of A's and B's where each string contain ABB as starting substring. Problem number 9, ABB as ending substring, right? So understand, this is going to be very tricky. Previously ABB as substring. Now ABB as starting substring, ABB as ending substring, right? Understand. Remember, starting substring means starting fixed. But when you say ending substring, string is keep on changing, right? Ending maybe keep on changing. But in the case of starting, once started, you cannot change it. But string is once ended. Further, you can increase the string also, right? But anyhow, you may not get what I am talking, so we'll see now. Right? First of all, before going to draw the DFA, first write the strings. ABB as substring, starting substring, ABB compulsory. Okay, starting is ABB. Afterwards, nothing there, no problem. Starting is ABB. Afterwards, one length string followed by one length. Starting is ABB. Afterwards, two length string. Starting is ABB. Afterwards, three length string. Starting is ABB and afterwards 4 length string and so on. Starting is ABB sigma star means anything. ABB starting compulsory. ABB starting compulsory, right? Yeah, that is the thing. So same thing below also. Right, let me check once. Let me check once. Just give me 1 minute. Some noise is coming. Right. So starting ABB confirm, ending can be anything. So remember minimal thing in this minimal thing, three length means four states. Start with four states. So see this one, S1, S2, S3, S4, final. So ABB. Remember, starting is ABB, afterwards anything. No problem. Right? Fine. Now some people are asking starting ABB, afterwards anything. Remember, first three symbols should be ABB. First three symbols should be ABB, afterwards anything. Some people are asking, sir, first symbol A, afterwards B, afterwards B, you will go to final. Okay. If the first symbol is B, dead state, no hope at all. Dead state behavior, it will go itself. Some people are asking, sir, after first symbol A, second symbol should be B. If second symbol A, then also no hope. Starting itself problem, I cannot do anything. Starting should be ABB. Next one, after S3 means AB already happened. After AB, one more B required. After AB, if A come, I cannot do anything. But remember this dead state concept you can avoid in the case of NFA. Same problem, minimal DFA asked. Then what is the answer? 5 states. Same problem, minimal NFA, dead state you can avoid 4. Dead state don't count. The things which are not part of our problem, we don't cover in the case of NFA. Some people are asking, sir, what is the regular expression? Can you see this one? ABB compulsory. After ABB, anything can come. A plus B whole star. It is a regular expression. After ABB, anything can come. A plus B whole star. Right? Let's come to here. ABB as ending substring. ABB as ending substring. Please try to understand ABB as ending substring. Right? Ending substring. So same story. Listen, same story. First, let me write the language. ABB first should be there. Okay. Next one. Understand. ABB should be ending before one length. ABB should be ending before two length. ABB should be ending before three length, and so on. ABB should be ending before anything. So sigma star. Right now, I think minimal thing is three length. So four states start. S1, S2, S3, S4. ABB, understand this. ABB. ABB. Right? Next one. Before ABB, anything can come. But remember it is a DFA. S1 on A already there. So A cannot be written again. Before ABB, anything can come. Before ABB, anything, because ending is ABB. Before anything, but on S1 already A there, so write only B. Okay, fine, that's okay. Now listen, everyone listen, ABB, it's a very, very interesting. It's a very, very interesting, please understand. After ABB, I am in the final state. Carefully, after ABB, I am in the final state. After A, I am in the S2 state. After AB, I am in the S3 state. After ABB, I am in the S4 state. Remember, ABB over means I am in the S4. Suppose after ABB nothing will come, I am in the S4 only. And one more, S4 is final because ending with ABB. Okay, no problem. After ABB, unfortunately, A came. That means ending three symbols should be ABB. but ending three symbols are not ABB, now BBA. So you cannot stay in the S4. After ABB, if you got A means your sequence gone. Last three symbols should be ABB, but it is a BBA, so it is gone. Now again you have to start. What is the meaning? So remember, only A over. A, after this A, again BB should come. Remember, S2 state indicate A over. Now you have A over. See, this sequence failed, okay, but at least, right? I think one symbol A is available. Ending is A there, but I want ending ABB. So go here. First to go here, A and BB will come. I will go to final. Next one. Suppose assume after ABB, B came, then see what happened. Last three symbols, not our format ABB. Right? Next one. Okay, last three not satisfied. At least last two in the ABB, two if you see AB, last two also not satisfying. It is a BB. Okay. In the ABB, at least one symbol also not satisfying. It is a B. So it's a completely gone. It is a completely gone. After ABB, if you get the B, if you get the, you have to start from starting. What is the meaning? B followed by again ABB. You have to go here. Right? Fine. Now understand one by one. Now understand one by one. Right? A, B completed. Now what about S3? Let's check. After AB, if B comes, no problem. After AB, if A comes. So remember, last three people not satisfied. At least last two should be, I want AB. AB also not satisfied. At least one person, yes, one person satisfied. One person satisfied. After AB, if you get A, go here. A followed by again double B. You will go to final. Every time make sure ABB should be at the end, then only you will go to final. Right? Next one. After S2, right? S2 means what? A over. After A, one more A, no issue. So if you want to teach, suppose after A, one more A followed by double B. See, last three people AB, no issue. So on S2, AB covered. On S3, AB covered. On S4, AB covered. That is, I think through practice it will come, right? So remember, you have to practice. Remember, you have to practice. Through practice, it will come. So for this problem, minimal DFA contain four states. And one more interesting thing I want to say to you, minimal NFA also four states. Because every DFA is NFA. And one more, no dead state also. If dead state is there, you can avoid. See, if dead state is there, you can avoid in the NFA. So one less came. Suppose no dead state, that itself is a minimal NFA also. Minimal NFA also four states. And one important question I want to say to you. One important condition, one important thing I want to say to you. Note, remember everyone, note. Right? See this one, note. If condition starting, if condition is at start, if condition is starting, if condition at start, if condition is at start, if condition is at start, remember, if condition is at start, in the DFA, dead state needed. If condition is at start, in DFA, dead state is needed. 2. If condition is at end, remember, at end, it will keep on changing. See, ABB ending. Careful everyone, ABB ending. After ABB, A came. So temporarily wait in the, see, ABB not there ending. Temporarily wait in the non-final. Go to correct non-final and wait. After this A, again double B, I will go to final. So if the condition is at the end, in the DFA, Get state not needed. If condition is at start, DFA, that state is needed. If condition is at the end, DFA, that state is not needed. Anyhow, NFA, that state is not needed. In both the cases, NFA means no that state is needed. Right? I'm thinking you got it. I'm thinking you got it. Okay, fine. Next, one more small thing I will say. One more small thing. I think problem number how many? 9 also over. Can you go to P10? Understand. It's also one more interesting thing. Construct minimal DFA for the language L is equal to construct minimal DFA for the language L is equal to construct minimal DFA for the language L is equal to try to understand this minimal DFA for the language L is equal to see this A AB ABB AB AB. I think 4 strings. Construct minimal DFA for the language L is equal to AAB, ABB, ABAB. So these are the strings. Remember, this is a finite language. It is a finite language. Finite language. Understand, this is a finite language because only 4 strings. Only 4 strings. Please remember, it is a finite language, right? Because only 4 strings. Because only 4 strings are there. Yeah, now understand. What is the minimal thing? 1. So with the 2 states start automata. With the 2 states start automata. Okay, I'm starting. So I think 1 means 2 states. S1, S2. It is also interesting problem. Understand everyone. It is also interesting problem. Understand everyone. Minimal string is 1. 2 states start. Okay, I started. 2 states start. I started. Now, if you okay, 2 states I started. That is absolutely fine. Now see what happened. After A, next minimal is AB. I think A. Next minimal is AB. AB. Already A there. B. B. S3 is also final. This completed. This completed. See, A is accepted because you are in final. AB also accepted because you are in final. Some people are asking ABB. 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 S4. Right? So A accepted, AB accepted, ABB also accepted. Okay, fine. Next. Some people are asking, then what about AB, sir? Remember, AB over means you are at here. AB over means you are at here. After AB, see this one, after AB, one more A required. AB once again. A, see this one. S5, A, AB followed by A, again B. See AB, AB. And if you understand one important thing, because of it is already finite language, no loop is present. See, no loop is there. It look like between S3, S4 loop there, no loop, check. Already it is a finite language, how loop will be there? Already it is a finite language, how loop is there? Right? If you want, you can act. If you want, you can try. All the things are possible under limit A possible, AB possible, ABB possible, AB possible. Right. Now some people are asking, sir, it is a DFA, It is a DFA. So if you observe clearly, all no starting with B array. I think just wait. Some WhatsApp may be already open. Just give me 1 minute. I will delete it. Sorry for inconvenience. Fine. Now fine. Now see, because of the finite language, right? So if you observe clearly, no string is starting with B. So because of DFA, if any string starts with B, go to dead state, maybe S6. Dead state behavior, it will go itself. Next one, I think if you observe clearly, after A, B okay. After A, one more A. No string having AA starting. Then dead state. After AB, B also possible, A also possible. See, after ABA, one more A not possible. Here also dead state. After, see, after all are over, 4 only. Right? So after this, if at all any A or B will come, you have to go to dead state. Otherwise, serious issue. So what I mean to say is, listen, what I mean to say is, only these 4 should accept, remaining all should reject. These white color things, whatever I written, DFA will ignore. Sorry, NFA will ignore. DFA have to cover. DFA having some extra responsibility. NFA don't have extra responsibility. That white color thing you ignore. That is called as, right, NFA. Now see this one, do this problem. Minimal DFA contain how many states? 1, 2, 3, 4, 5, 6. But minimal NFA contain 5 states. You can ignore that state. Because that white color things, if you remove, that is called NFA. Some people are asking, sir, why you written white color thing? DFA should accept only these 4. If you give other than these 4, it will reject. So one important thing I want to convey from this problem. What is that one? Right? If you write DFA for the finite language, compulsory dead state required. Note. 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 If you construct. Careful. If you construct DFA for, if you construct DFA for finite language, if you construct a DFA for finite language, if you construct DFA for finite language, if you construct DFA for finite language, dead state needed. It's a very, very important point, dead state needed. If you construct DFA for finite language, dead state is needed. If you construct DFA for the finite language, dead state is needed. Okay, I think everyone is okay. This is a very, very important one. This is a very, very important. It's a problem number. It's a problem number 10. Problem number 10. So please be careful with the note. Right? And one more. Problem number 9 also. Problem number 9 also. I written the note. This also please remember. Please remember. Ending condition, no problem, because ending no limit. See, remember everyone. Oh, I will give one nice example. Your date of birth you cannot change, but your expiry date you can change. If you have good habits, you will stay in more days. If you drive slowly, right? Maybe you can increase your expiry date, right? And one more, if you don't harm anyone, your expiry date you can increase. Means what I want to say is ending will be keep on changing depending upon your habits. But starting date you cannot change it because it's already done. Starting date I cannot change. Ending date I can change. Ending date I can change. If I do good things, I may have more lifetime. So that's what this note is saying. If condition is at starting, I think I cannot do anything. Dead state compulsory. If condition is at the ending, what is the condition? Ending with ABB. I think ending with ABB. Na? If not, I will wait in the non-final. After some time, again ABB will come. I will go to final. But you have to wait correct non-final. After ABB, if A comes, ABB, A comes. I think last three symbols are not ABB because ABB followed by A there. Last three symbols are not ABB, but A is there. A is in the ABB. Afterwards, A came. So last three symbols not ABB, but at least last symbol A. So last symbol A means I think this state. Go to A comes, go here, followed by BB. So ending is keep on changing. So ending purpose dead state is not needed. Right? Fine, perfect, very good, very good. Problem number 10 over. Let's go to problem number 11. Let's go to problem number 11. Let's go to problem number 11. Right? Construct minimal DFA for the language L is equal to construct minimal DFA for the language L is equal to all strings are A's and B's where each string length is at least 3. Where each string length is at least 3. Right? So first of all, before going to solve this problem, all strings of A's and B's where each string length is at least 3. Minimum 3. Write the language first. Minimum 3, na? So minimum 3 means 3, 4, 5, and so on. Minimum 3. So if the minimum string is 3 length, 3 plus 1, 4 states. Start attempt. S1, S2, S3, S4. Right? Next one. First symbol ARB. Second symbol ARB. Third symbol ARB. So minimum 3 over. Afterwards anything, no objection. So this is the DFA. It is a minimal DFA. If you want, you can check. Everywhere AB covered. S1 A there, S1 B there. S2 A there, S2 B there. I think that's fine. So minimal DFA contain, right? I think at least 3, na? I think 4 states enough. Suppose at least n, n plus 1 states. Construct minimal DFA for the language L is equal to all strings of A's and B's where each string length is at least 3. At least 3. Right? This is, suppose at least n plus 1. 3 means 4 states, n means n plus 1. If you want, you can verify. Right? Perfect. N of A also same because no dead state. If no dead state, minimal n of A also same. Right? Be careful. Every DFA is n of A. Every DFA is n of A. Because of no dead state. In the n of A, no dead state. Here also no dead state. So if at a question is given, same thing, minimal n of A, same story, I think. Right? And one more, do you know this or not? C programming is freely available on the YouTube also, EPT also. Python programming also freely available on, right, YouTube also and EPT also. Discrete mathematics also freely available. Please utilize. Right? And one more, right? See this one. Actually, see this one. Assignments for each subject, 300 questions assignment is there. For each subject, 300 questions assignment is there. Quality questions, good questions, 300 questions assignment. I request everyone, please utilize. Toppers notes also available. Please utilize that. PYQs also available. Doubt solving also there. Daily tests also there. Mark tests also there. Please utilize. Right? These are all things. Actual cost is around 7,000. We are giving freely. In the EPT website, these all are available freely. Please utilize. Zero cost. Freely they are available. Please utilize. And one important thing I want to say to you. So my goal is I want to make Because when I'm student, I face a lot of difficulty because of financial issues. I want to give education as minimal cost as possible, as affordable as possible. So affordable courses are there, very less price. Please go and take it, right? So recorded classes are there, live is not there. To make it affordable, we make it as live. We make it as recorded. RIC course is not there, test series also not there, but mentorship is there. Every weekend we will give target. Every weekend we will give target. Right? 6 months course there, 12 months course there, 24 months course there. Please utilize. Next one, premium courses contain every possibility. If you take this course, you will get the marks 100 out of 100. If you utilize properly, you will get 100 out of 100. 6 months course there, 12-month course there, 24 months course are there. Everything is available. If you take this course because a few things are missing, you may get 80 marks out of 100. Right? You may get 80 out of 100 because see, I think you don't have a live, you don't have RIC course, you don't have test series. That is the reason you may get little less. But this course also better, this course also good. Whatever you want, you can take. Next one, almost free resources. Right? EPT world lectures. We are kept and we kept almost free. Almost free. You can utilize, right? So recorded lecture. World lectures will be there, very minimal price. Almost free. Just you have to pay GST and right platform fees. Minimal price. Right? Mentorship also there, recorded is there, but old lectures, remember. Right? So this is, I think, yeah. I think this is also 365 days. As of now, 365, it may change also. Next one, GATE plus placements. GATE and placement combinedly we can prepare. It is also premium course. GATE plus PSU plus, right? GATE plus PSU plus UGC net. This is also, right? You can utilize. Only test series, that is also you can utilize. Only test series, that is also you can utilize. These are wonderful things, right? EPT courses now for 1,000 rupees also you can access. Don't spend lot of money for the, don't spend lot of money for the courses. 1,000 rupees also now available. Utilize whatever you want. Whatever you want, you can take. Right? Now go to the next one. Same problem, construct minimal DFA. I think previously is problem number 11. Na? Previously problem number 11. Let's go to problem number 12. Let's go to problem number 12. Same. Previously at least 3. Now at most 3. At most 3. At most 3 means what? Maximum 3 means epsilon, means 0 length, 1 length, 2 length, 3 length. 0 length means epsilon. 3 length means triple A to triple B. 2 length means double A to double B. 1 length means A to B. So these only around at most 3. So here minimal string is epsilon, which is 0 length plus 1 with 1 state start automata. So S1 state start automata. Epsilon accepted. Next one, some people are asking 1 length also. That 1 length may be A or B. It is also should be accepted. Maybe 2 length also. A, B, right? A or B followed by again A or B. 2 length also. 3 length also. Right? But remember, more than 3 not allowed. Compulsory dead state. Compulsory dead state. Remember, at most 3 means it is a finite language. Every finite language for a DFA needed, right? Dead state. Dead state will go itself. So careful. At most 3. At most 3. So because of at most 3, right? So I think already 4, but 1 dead state required. At most 3, 3 plus 1, because 3 length string also you have to handle. So 4 states plus 1 more for dead state. So at most n, suppose at most n plus n length string, n plus 1 states, 1 for dead state. So finally n plus 2 states. Here 3 plus 2 states. So please be careful, it's a note. Because of DFA, dead state is needed. And one more, it is a condition at the ending, because maximum 3, more than 3 not allowed. More than 3 dead state will come, right? Fine, that is a problem number 12. Let's go to problem number 13. Exactly 3. Exactly 3 means 3 length only. Triple A to triple B. Triple A to triple B. Exactly 3. Triple A to triple B. So 3 length, na? So when you say exactly 3 length, minimal also, maximal also. 3 means 4 states start. S1, S2, S3, S4. First one may be ARB, second one may be ARB, third one may be ARB, right? More than 3, dead state compulsory, because it is a finite language. So 3 plus 1. 3 means 3 plus 1 states required, plus 1 for a dead state. Total 3 plus 2. Minimum DFA. If it is n of a, dead state you can ignore. If n of n, dead state you can ignore. Suppose exactly n plus 1 for n length, 1 for dead state, n plus 2. So remember, these are very, very important. These are very, very important. Please be careful. 13 problems I done till now. 13 problems I done till now. Right? Let's go to next. Problem number 14. Careful everyone. Problem number 14. Construct minimal DFA for the language L is equal to. Construct minimal DFA for the language L is equal to. Construct minimal DFA for the language L is equal to. All strings are A's and B's where each string length divisible by 5. All strings of A's and B's where each string length, here length only matters. A or B doesn't matter. Here length only matters. Where each string length is divisible by 5. Where each string length is divisible by 5. Let's wait. Yeah, perfect. So what is the answer for this? Let's see. First what you do is understand one by one. Each string length is divisible by 5. I think 0 length, 0 divisible by 5. Yes. 5 length also, 10 length also, right? 15 length also, 20 length also. I think multiples of 5. Be careful. First understand. Lengths only matter here. Lengths only. What string doesn't matter. Length is what? Inside yes, B is there. Just count length. 0 length okay, 5 length okay, 10 length okay, 15 length. So remember, 0 length. Okay, accepted. Everyone understand? 0 length accepted. Okay. Fine. Next one. Some people are asking, sir, what about 1 length? Not accepted. 2 length? Not accepted. 3 length? Not accepted. Remember everyone, state number 4 indicate 3 length string is completed. State number 3 indicate 2 length string is completed. State number 2 indicate 1 length string is completed. State number 1 indicate nothing over. Nothing completed. 2 indicate 1 length. So every state will remember something. If you want to remember something, state the change, right? State change. You want to remember something new, change the state. You want to remember something new, change the state. You don't want to remember something new, like say, keep the loop or go to previous. Right? So now see this one. I think state number 4 indicate 3 length string is completed. State number 4 indicate, 5 indicate 4 length string completed. Right? Now see this one. And after 4 length, one more length. Go to final. 0 length accepted, next 5 accepted. Do you believe or not? Right? 5 accepted, 6 rejected, 7 rejected, 8 rejected, 9 rejected, 10 accepted. Oh. Oh, who is calling here at this time? Fine. Right? So after 5, 6 rejected, 7 rejected, 8 rejected, 9, 10 accepted. Afterwards 11, 12, 13, 14 rejected, 15 accepted. So when you say divisible by 5, divisible by 5, it is an infinite language. Infinite language. When you say infinite language, loop compulsory. Loop needed. Somewhere you have to go back. Divisible by 5, infinite language, means loop needed. Infinite language, I cannot change the state every time. Somewhere you have to come back. So I want to say one important note to you. See this one. Everyone listen. DFA, minimal DFA, minimal DFA, divisible by 5, needed 5 states. Check if you want. Minimal DFA where divisible by 5. Length of the string is length of the string. Divisible by 5 needed 5 states. Length of the string divisible by n needed n states. Not only DFA, NFA also same because no dead state. Because of no dead state, so minimal DFA also 5, minimal NFA also 5 because every DFA is NFA. Okay, fine. You are absolutely fine. Let's go to problem number 15. See this also. Construct minimal DFA, construct minimal DFA for the language L is equal to, it is also important, see, all strings are A's and B's, where each string contain number of A's divisible by 7. Remember, construct minimal DFA for the language L is equal to all strings of A's and B's where each string contain number of A's divisible by 7. Where each string contain number of A's divisible by 7. Right? Try to understand what it means. Here remember, count only A's. What about B's? B's may come, may not come. Number of A's divisible by 7. Can you see this? Can you see this small twist? Number of A's divisible by 7 means 0 A's, 7 A's, 14 A's, 21 A's, 28 A's, multiples of 7. But remember A's only. 0 A's. Okay. Next. 1A rejected, 2A rejected, 3A rejected, 4A is rejected, 5A is rejected, 6A is rejected, 7A is accepted. Right, 6A is rejected, but 7A is accepted. After 7, next 14 accepted, 21 accepted, 28 accepted. Some people are asking, what about B's? B's may come, may not come. You can keep simply loop everywhere. These may come, may not come because of DFA. Na? In every state, you have to cover it. So S1, S2, S3, S4, S5, S6, S7. So here, see this one. Minimal DFA for the language, number of A's divisible by 7 contains 7 states. 7 contains 7 states. Minimal DFA number of A's divisible by n contain n states. Right? Perfect. Perfect. So 15. I'm stopping at 15. I'm stopping at 15. I'm stopping at 15. Tomorrow's class we'll see further. Tomorrow's class we'll see further. Please go through all these things. Please go through all these things. I want to say one important thing to all of you. I want to say one important thing all of you. I want to say one important thing all of you. Right? So RIC course test series from these two last year almost like both combined like 50 plus questions came in the previous right last year. RIC test series combined 50 plus questions. Many students sent the message also, sir. Most of the questions came from RIC test series. It contained most expected questions. Using our experience, we made the nice thing. Last 6 months, this is very good for practice. RIC and test series combined. This is called Combo RIC course. Combo RIC course. It will be really helpful. It is meant for last 6 months. Please utilize. Please utilize. It is meant for last 6 months. Right. So tomorrow's class we'll see remaining, and these are the people who taken the EPT placement course. They placed in the big companies. These are our placement courses: DSA course, DSA plus system design course, DSA Super 50. Means these are practice courses, interview course, language course, development courses. So languages, these two languages are free. And remember 60% discount going on, utilize. 60% discount going on, please utilize. Thanks, thank you. See you in the next class. See you in the next class. Chalo. Thanks everyone.